G'day guys, we've got an applications of calculus question for you today. Now the question tells us that we have an area of a sector of a circle of radius r is 50 centimeters squared. We're asked to use calculus techniques to find the least possible perimeter of the sector. So I've copied and pasted a circle with a sector in it into this document, guys, to make it easier for us to work out or understand what I'm doing. And we've got this sector which has a radius of r. So let's just write that in. We've got a radius of r and an area of 50 centimeters squared. So let's just write that one in. We've got 50 centimeters squared, and that's our area. Now the angle here which subtends this sector is going to be equal, we're going to call it theta, and we're going to call this arc, which is going to be part of the perimeter from this point here to this point here, we'll call this L. Now we've got a couple of equations that we're going to have to work out first before we're able to get an equation that we're going to be able to solve to find the least possible perimeter. First of all, we're going to have to work out what the perimeter is going to be expressed as. So let's start with that. We've got perimeter, guys, is equal to, we've got r plus r, so 2r plus L. Now we know, guys, well, hopefully you guys know that I can work out an arc of an angle subtended at the center of a circle by using the formula. We can say that R or L, is equal to the radius times the angle, and the angle is in radians. Cool. So what we're also told is the area of this sector is 50. So we can use the area of a sector formula in radians, which is A is equal to 1/2 r squared theta. And we can fill in what we know. So that's equal to 50. Cool. So what we're going to do is we're going to use our perimeter formula. We're going to replace L with this r theta, and we get P is equal to 2r plus r theta. Now what I'm going to do, guys, is this area formula, I'm going to rearrange it so we have theta in terms of radius. So let me just do that now. So I'm going to take the half to the other side, and I get 100. So this will end up as theta is equal to 100 divided by r squared. Cool. And then, sorry about all the arrows, guys, but then I'm going to substitute that into here. So what we get in the end, guys, is we have a perimeter in terms of simply radius, which is equal to 2r plus r, and instead of writing theta, we're going to write 100 divided by r squared. Cool. So we can simplify this out a bit. We can cancel out one of the r's with the base, and we're going to move the remaining r into the numerator so it's easier to differentiate, and we get perimeter is equal to 2r plus 100 r to the power of -1. Now I'm assuming you know all the index laws that are associated with moving that r up to the top or up to the numerator. Okay, so now I've got my perimeter in terms of radius. What I'm going to do is I'm going to differentiate this function here. So I'm going to get dp dr, and this is going to be equal to 2 minus 100 r to the -2, which we can leave with positive indices by going 2 minus 100 on r squared. And because we're looking for an optimal solution, At an optimal solution or a turning point in the function, the first order derivative is always equal to 0. So what I'm going to do, guys, is I'm going to rearrange this formula so I can solve for r squared. So I'm going to take the 100 over r squared to the right-hand side, and I'm going to get 2 is equal to 100 over r squared. I'm going to multiply both sides by r squared and then divide both sides by 2, and I get r squared is equal to 50, which means that r is the square root of 50, or 5 times the square root of 2. Cool. So from here, guys, what we're going to do is we're going to use this radius to calculate the perimeter. So I'm going to substitute this radius into our perimeter formula, which we find is equal to, if I rearrange this again, it's going to be 2r plus 100 over r. So I'm going to change colour to make it easier to see. So this is going to be, we're looking for the perimeter when the radius is equal to 5 times the square root of 2. So that is equal to 2 times the radius, so I'm going to go long form here, 2 times 5 square root 2 plus 100 divided by 5 square root 2. Cool. So this is going to equal 2 times 5 is 10 square root 2 plus 100 on 5 is 20. So we have 20 on square root 2, which we're going to rationalize, which equals 20 root 2 on 2, or 10 root 2. So we have 10 square root 2 plus 10 square root 2. And therefore, guys, the perimeter, or the minimum perimeter for this scenario is going to be equal to 20 square root 2 centimeters. Cool. So that's the problem, guys. Now let's just run through what we did. First of all, we went through our question and we drew a picture, or in my case, I copied and pasted a picture into my whiteboard here, and I put in all the information that I knew. The reason I draw a picture is because it makes the problem a lot easier to visualize. If you're sort of new to this, I would say the picture is vital. What we then do is I basically start collecting all of the formulae that I might need. So when I was first starting this, I might even collect too many formulae that I might not even use throughout the whole thing. But it's important to have too many, or it's better to have too many than not enough. So the first one was my perimeter in terms of the radius and the arc length. I then had my arc length in terms of the radius and the angle that the sector subtends. And then I also had my area of a sector formula. What I then did is I inputted the information that I needed, or that I was given, sorry, and then was able to sort of derive a perimeter, or a function for perimeter, which is in terms of exclusively the radius. Once I did that, I differentiated that function, set it equal to 0 because we know that that's an optimum point, and then solved for the radius. Once I'd done that, I substituted this radius that I found out, this one here, I substituted that back into the original perimeter formula, and then I was able to come out with the final minimized perimeter of 20 square root 2 centimeters right there. So guys, I hope this video helped. If it did, give it a thumbs up. If you'd like to, you can subscribe to my channel. I put out new videos all the time on maths, science, physics and chemistry. But in any of these kind of problems, guys, you must make sure that you practice by doing. There's only a certain amount of notes that you can actually write on topics like this. You must start doing practice problems and start bashing your head against the wall, I guess, when you're trying to figure out how they work. Because the more that you bash your head against the wall, the more chance you've got of the wall falling down. So just keep on plugging away. They're called maths problems for a reason. If they weren't difficult, you shouldn't be doing them. But yeah, just keep on keeping on, guys. Make sure you stay enjoying it. But until next time, guys, just keep enjoying your maths, please.